CERN was created in 1954 to understand why the universe exists and why it looks the way it does. The LHC, the Large Hadron Collider, is the biggest and most complex machine ever built. It is 27 kilometers long and about 100 meters underground. Inside the accelerator, two beams of high-energy particles run close to the speed of light and hit each other. These collisions create a huge amount of data.
Thanks to this data, it has been possible to actually discover the Higgs boson.
The technology produced by Oracle in databases and more recently cloud computing is essential to be able to scale out our operations to the levels that worldwide physics research requires today.
Please welcome Larry Ellison.
Hi, everybody. Let's see. Thank you for joining us here today at Oracle OpenWorld. And I'm here to talk about our Generation 2 cloud and Oracle autonomous infrastructure. Autonomy is the defining technology of a second-generation cloud. Autonomy is what separates a second-generation cloud from what came before. Last year, we brought you Oracle, the world's first autonomous database. This year, we've been working on a number of other autonomous services that we're adding to our cloud as we march towards our ultimate goal of delivering the world's first complete and truly autonomous cloud. As we discussed last year, autonomous systems are enabled by a radical new generation of artificial intelligence called machine learning. Autonomous systems are charismatic. We know them really well. We pick up our telephone and it recognizes our face and logs us in without having to look at our fingerprint or us having to enter a password. It's called machine vision. But it also is what's enabling a soon-to-be generally available autonomous vehicle. On Tesla, we're very excited, hopefully, to get that car out pretty soon and before anybody else. And it's really interesting because there are tremendous benefits to autonomy, some of which are economic, some of which are more important than savings. For example, autonomous driving, yeah, it will cut your Uber bill in half, and that's important. But 30,000 people a year die on our highways. By eliminating human labor and eliminating human error, by eliminating pilot error, autonomous systems are going to save tens of thousands of lives. The autonomous database also has some interesting benefits, which I'll get into. And ultimately, our goal is to deliver to you a fully autonomous cloud. Artificial intelligence, machine learning, autonomous systems are so fundamentally different than what came before. It marks a new generation in computer technology. The benefits are really very simple to remember. Autonomous systems eliminates human labor. And when you eliminate human labor, you eliminate pilot error. It's a very, very big deal. The scale of the benefit of eliminating human labor is enormous when running computer systems. We spend much more on people than we do on storage or compute or anything else. Any of our physical assets, the cost of our physical assets are way outweighed by the cost of our human assets in running these complex systems. Eliminating human labor is one of the economic benefits, the biggest economic benefit of this second generation cloud. But that's layered on top of the economic benefit of the first generation cloud, which is only paying for what you use when you use it. So resource sharing is on top of, you get that in the second generation cloud, on top of saving human labor. But back to this eliminating human error, which to me is much more important than the economic savings. If you eliminate human error in autonomous cars, you save tens of thousands of lives. If you eliminate human error, pilot error if you will, in autonomous systems, you eliminate data theft. In fact, as far as I know, it's the only way you can ever eliminate data theft. Okay, so clouds are complicated. Human beings make mistakes. The Amazon data breach, where Capital One had 100 million of their customers lose their personal information, happened because someone made a mistake. Someone made a configuration error. It was a pilot error. Now, Amazon takes what I think is a very reasonable position, saying, hey, you misconfigured the system. That's your mistake. We at Amazon can't be responsible. If you spend the night drinking and get into your Ford 150 and crash it, that's not Ford's problem. If you get into an autonomous Tesla and it should drive you home safely. So Amazon's support policy is very clear. As a customer, you maintain full control of your content and responsibility for configuring access to AWS services. That's on you. In the Oracle Autonomous Cloud, when you use the Oracle Autonomous Database, it configures itself. It's not possible for customers to make configuration errors because there are no pilots to make errors. The system configures itself. So, in the AWS cloud, if you make an error and it leads to catastrophic data loss, that's on you. In the Oracle cloud, when you use the autonomous database, the database automatically provisions itself. The system automatically configures itself. It automatically encrypts itself. It automatically backs itself up. All the security systems are automatic. Human beings aren't involved. There can be no human error. In the Gen 2 cloud, the autonomous database is responsible for preventing user errors. The system is responsible for preventing data loss. Not you, us, or more precisely, our automated systems. One simple rule. This is not complicated. Clouds are complicated. People make lots of decisions configuring these things enormously complicated. I'll give you one simple rule to prevent data theft. Put your data in an autonomous system. It's the only rule I can come up with. Only thing anyone's come up with so far. No human labor, no human error, no data loss. That's a big difference between us and AWS. Okay, so we introduced the autonomous database back in 2018. I mentioned it provisions itself, configures itself, encrypts itself, all that stuff. It also does elastic scaling. As you need more capacity, it adds compute. It adds storage. It constantly tunes itself. So there's more automation involved than just security and fixing bugs. It also runs really fast. And it continues adjusting and tuning itself constantly. Again, It meets the promise of a second generation cloud of being autonomous, but also it's elastic and serverless. But if you want to be critical, and why not? You say, does the autonomous database, is that the only thing you run in your cloud? So the autonomous database, it patches itself while it's running, and it configures itself, and does all these things. I mean, that's great. But if I remember anything about computing, doesn't the database run on an operating system? I mean, isn't that database sitting on a lot of other code? I mean, specifically the Oracle Linux operating system, Oracle's version of the Linux operating system. So, hey, it's great you got an autonomous database. It sounds like the vulnerability then is the code right below it, the operating system. What are you going to do? What are you doing about that? Well, today we're announcing the Oracle Autonomous Operating System, our version of Linux, which we've been working on for almost 20 years, believe it or not, is now autonomous. The new version of Oracle Linux is autonomous. It is the first and it is the only autonomous OS in the world. And it's live. It's pretty cool. Thank you, Ed Scrivet and Wim and the huge team of people who've been working on this. I think Wim's only been working on it 20 years. It took Wim a long time to get this right. But he stuck it out. It's a big job. Building these systems, by the way, is hard. It's complicated. We've been working on the database for a long time. We've been working on the OS for a long time. It's not easy. There's a reason why, we had the first autonomous database. Been working on that problem for a long time. First autonomous OS, 20 years of effort. So it runs our cloud. It runs all of our applications run on autonomous Linux. All of our infrastructure runs on autonomous Linux. Hundreds of thousands of servers, hundreds of millions of transactions a day. Proven itself. It's live in our cloud. It also runs all of our appliances like Exadata. And we support thousands of customers who run our Linux, Oracle Linux, on-premise in their place, as opposed to running Red Hat. They run our Linux. And availability, it's down around, kind of guaranteed to be down 2 minutes a month. It's a highly available system designed for the cloud. And this looks familiar, right? Like the database, it provisions itself, it scales itself. It tunes itself. It does it all while it's running. It patches itself while it's running. You discover a security vulnerability in Oracle Autonomous Linux, and we fix it, and you don't even know. There's no outage. There's no downtime. There's no delay. Once a vulnerability has been detected, we fix it while it's running. Equifax had a problem. A year ago, I think I talked about Equifax. And they were patching a database called Apache Struts, or data store, or whatever you want to call it. We'll call everything a database. So they were patching Apache Struts, and first they had to find downtime. When can you go do this? When you can take these systems down? Actually, the vulnerability they'd known about for 6 months, but they finally got some downtime. They took it down. They patched. Most of the instances, the majority of the instances of Apache Struts they patched, but they couldn't find a few. It's a manual process. Couldn't find a few. Disastrous, catastrophic data loss. There are no human errors. There are no omissions. We don't miss anything. There are no delays. There's no waiting and scheduling of downtime. It patches itself while it's running. And we patched the entire fleet, millions of cores. In fact, when the Spectre meltdown bug showed up, we actually had to patch our entire cloud because we use it's a bug on Intel chips. We had to patch our entire fleet of processors, of cores, of systems, of CPU, whatever you want to call them. We had to patch the whole 150 million patches. We applied to our entire cloud in 4 hours, no downtime. No downtime. All fixed, kept running, proven, done. No one else, nobody else can do that. We've been in the Linux business since 1998, and again, 20 years. We've been developing Linux. We started supporting customers who were preferred running our Linux to Red Hat. We've been doing that since 2006, so we've been in this business for a very, very long time. So again, it's not like we just discovered Linux. We've been working on this, we have a large team of people working on this for a very, very long time. Because we felt we needed, running underneath the Oracle database, we felt we needed a highly reliable, highly scalable, highly available OS to go with our highly reliable, scalable, available database. And we started this before the cloud generation, but now the cloud generation is here. It is exactly what we need to pair with our database and our other autonomous services. It's designed for extreme performance, high reliability, always secure. In that sense, it's different than Red Hat, which is designed for kind of traditional on-premise applications. But we're completely compatible with Red Hat. Any Red Hat application will run unchanged on Oracle Autonomous Linux. In 13 years, not one compatibility bug has ever been filed for Oracle Linux. Every Red Hat application runs unchanged on Oracle Linux. We have thousands of customers that we support, thousands of ISV applications. So, it's very, very, you can rest assured that your application will run unchanged if you move it from Red Hat to Oracle. But there are differences. We're designed for extreme performance. We're designed for high reliability. We're designed for high security. Oh, and one more thing. And our Linux is autonomous. It's interesting, some of the people have chosen to use, some of the customers have chosen to use Oracle Linux in their cloud. The Oracle Linux that they have in their cloud, if they're updated and current, is the Oracle Autonomous Linux. AWS, Salesforce.com, IBM Software. Now in full disclosure, and of course our cloud. In full disclosure, since IBM bought Red Hat for $32 billion, they are trying to move off of, as much as possible, Oracle Autonomous Linux and onto Red Hat. But they still use Oracle Autonomous Linux, right, to this day. Highly available, reliable, and secure. Very easy to do conversion. Anyone thinks, hey, I'm running a Red Hat now, I want to move to the Oracle Cloud. How hard is it to convert? This is what you got to do. Almost nothing. You point your servers to our Linux update server, you're done. No reboot, no nothing. It's a one-step, literally instantaneous migration. And when you use Oracle Autonomous Linux in the cloud, the price is just right. It's free. So if you're paying IBM, you can stop. Okay, Oracle Autonomous Database. Hides complexity. It's the easiest system to run, and it's the lowest cost to run. It's actually the Oracle Autonomous Database. If you want all those benefits, if you want to eliminate data loss, you want to patch online, you want automatic tuning, you've got to be willing to pay less. We automate, it's true. It's fascinating, isn't it? It costs way less to run Oracle Autonomous Database than it costs you to run Redshift or Aurora or any of the Amazon databases. It's way cheaper and way safer. We automate not just the database, but we automate all of the infrastructure around the database, this compute and the storage. And It's easy to use because there's nothing to learn. It drives itself. And there's nothing to do because it drives itself. It does all of this stuff automatically. You can concentrate on building systems that are related to your business rather than worrying about the underlying plumbing. Now, I said that when you eliminate human labor, you eliminate human error. And that's great. Human errors cause data loss. Human errors cause systems to go down. Well, it's great to get rid of human labor and get rid of human errors, but those aren't the only kind of errors, by the way. Servers fail, storage fails, networks fail. Lots of things fail. Well, the Oracle Autonomous Database not only eliminates human errors, but it's configured in such a way that the network can fail and the system keeps running. That a server can fail and the system keeps running. You're not even aware of it. Even you could have a failure in our database software, and that fails and the system keeps running. It's a fault-tolerant system. It tolerates hardware errors, it tolerates software errors, it tolerates network errors, and it eliminates human errors. That's why we're at least 25 times more reliable than Amazon. That's a very conservative number. Though they don't think so in all the email they send me. I think I might change it next year to 100 times, but we'll see. Oracle Autonomous Database is much, much, much faster than Redshift. You know, we showed actually the Oracle Autonomous Database being 7-8 times faster than Redshift when you're doing analytics. And by the way, Amazon's database for doing analytics is Redshift. That's their best analytics database. We're 7 times faster. Aurora is the best transactional database. We were, again, around 8 or 9 times faster. But if you try to do analytics, a mixed workload, analytics and transactions on one of the Amazon databases, we're 100 times faster. But forget that, 100 times faster. But let's say you're just doing analytics, 7 times faster. Time is money. You're paying by the hour. The hourly charges are around the same. They're 7 times slower. That means they're 7 times more expensive. That's why it's so easy for us to guarantee. You take any application off an Amazon database, move it to Oracle, we'll guarantee, bring in your Amazon bill, we'll guarantee, well, it's not a contract, we'll guarantee that bill will go in half. I'm just going to go through these very fast. Revenue forecasting, 6 minutes to 2 seconds. That's a big improvement. You pay for the 6 minutes, 2 seconds is cheaper. 40 times faster. That's 40 times cheaper. By the way, the comparison was versus an on-premise estimate. But in the cloud, if you're 40 times faster, you're 40 times cheaper. On-premise is very different, depends how you depreciate the hardware and all this other jazz. Software is their business. Software is their business. Move to the Oracle Cloud. That's the Autonomous Database is really autonomous transaction processing. That's what ATP stands for. 100 times faster than their prior system. If you want the benefits of the Oracle Autonomous Database, you've got to be willing to pay less. In some cases, a lot less. Thousands of new customers. I'm not going to go through them all. I could stand here and try to go through a few thousand new customers, but I think even Safra would leave. You know, she might be the last one, but I think it would be pretty grim if I tried that. The Autonomous Database comes in 2 flavors. One is shared infrastructure, where you're in there with a bunch of other tenants, and that's designed to optimize cost. The other is dedicated infrastructure, where you're kind of on your own machine, on your own storage, on your own subnet, and there are no other tenants in there with you. Okay. By the way, in both cases, they're serverless and elastic. And by the way, in the dedicated infrastructure, what I mean by serverless and elastic in that case is any one application running in that zone, when that application stops running, it's not using a server. When that application is running, it gets more servers as it needs it. So in both cases, they're serverless and elastic, but in one case, you're in with a lot of other tenants. In the other case, you're in a protected zone. Okay, the simplest one is the shared infrastructure. All you do is say how many cores you want, how much compute you want, how much storage you want. Boom, you're up and you're running. And it's very inexpensive indeed. And it's, as I say, it's elastic. If you need more capacity, it will just automatically, you set a policy and it will add as many servers as your policy allows for. But it does it online. When this thing scales up, it's still running. If you go from one server, or core if you prefer, one core to 10 cores, there's no downtime. It just does that automatically based on the policy. And then when you no longer need the 10 cores, it goes back to 1 and stops running, it goes to 0. Amazon doesn't do this. Their databases don't automatically scale up and down. And there's a very low minimum commitment of time. It runs, an hour. This is really true pay. You pay for what you use when you use it. The dedicated infrastructure, which is new this year, is quite different. Here, this is a private reserved pool of resources, specifically Exadata machines, Exadata machine or machines, that only your company is using. And that's reserved. You're the only tenant. It's single. You're the only ones there. And there's actually a bunch of perimeter control computers around you, preventing any messages or anyone from looking as to what's going on in the secure isolation zone. So when you've got dedicated infrastructure, not only are there no other tenants, there's no way for another tenant to get in, to tunnel in to the Exadata machines or any of the hardware resources that you're using. We create these secure isolation zones using these things called perimeter control computers. And it's very interesting. I think I covered this last year. Our hardware, the hardware in our cloud is very different than the hardware in all the other clouds. All the other clouds have basically a shared Intel computer. And who shares it? Amazon got code in that computer, and you've got code in that. At the very minimum, you might be the only tenant in that computer, but you share that computer with Amazon. Amazon also has code in there. It's not how ours work. In our case, you're the only tenant, and our control code, our network control code, is in a separate computer with separate memory. And that forms these secure isolation zones. So threats can't get through the main, can't get into the cloud. And let's say someone comes in with a credit card, and and there's some shared zone, and they have malice on their mind, and they want to go prowling around. They can't get out of their zone into your zones. Threats can't enter, and threats that have somehow gotten in can't spread into the isolation zones because the perimeter control computers block them. Gen 1 cloud, one shared Intel computer, Amazon's code. Amazon can see your data, and you can see Amazon's code. Both really bad ideas. You should not be able to access cloud control code. They shouldn't be able to access your data. In our case, you've got a dedicated computer that has only your code in it and only your data in it, and we're off, and our control code is in another computer with a different memory system. And again, we're the only one who's actually got fundamentally different hardware configurations than all the other clouds. All the other clouds are these Gen 1 clouds with one shared computer. They don't have these perimeter control computers. The Oracle database. Again, we've been doing this for a long time. And we're constantly adding features to the Oracle database. It's very interesting. When we compared ourselves to Amazon last year, we took the Oracle database and we compared it to Redshift, which was Amazon's analytic database. But then we said, well, what about transaction processing? Oh no, Amazon has a completely separate database for transaction processing called Aurora. So to be fair, when we want to do analytics, we took the Oracle database and said, okay, we're going to do analytics versus Redshift, their best analytic database. We're going to compare transactions. We'll do Oracle against Aurora for their best transactional database. And you think, oh wow, okay. Well, and then of course we did that experiment where we ran a mixed workload, and we're 100 times faster because they had this idea of they're specialized. Their analytic database has columnar data format, which we have in Oracle. Their transactional system has a row data format, which we have in Oracle. We have both. We support both together. And this is just the beginning of a divergent architectural strategy that would, the one at Oracle where we say, no, we're going to keep adding features and data types and application types to the Oracle database. A single database, a single converged database that handles all your data types and all your applications. Versus Amazon saying, no, when something new comes up like the Internet of Things, we'll give you a real fast IoT database. We'll give you separate, in fact, we have lots of databases. We think that's a really interesting idea, but leads to lots of problems. We have one converged database that supports all your applications, all your data, that's autonomous, patches itself while running. Think what Amazon's got to do when they have 5 different databases. They got to build 5 autonomous databases. They got to build 5 databases that patch themselves while running. It's impossible. It's impossible. So what you get when you have all of these, and by the way, it's counter to fundamental trends in the digital world. Your smartphone now is a camera and a calendar and a messaging system, and as Joe Biden would say, a record player. It has all of these things. It's okay, I would have said stereo. Joe's a little older than even I am, what can I say? So, but it's this one amazing device that does all of these separate things, and it's very, it's very, very convenient. One power supply, put it in your pocket. We have the same idea at Oracle, converged system. So we're a relational database, but we're also an in-memory database. We support JSON, and before that, XML. We support machine learning. We have blockchain transactions built into it, sharding. All of these things, all of these capabilities in one database. Amazon has a separate database for all of this. And that creates a bunch of problems. Okay, so each one of these databases has different APIs, different application programming interfaces. So if you're writing a program and you have 3 or 4 different data types and talking to 3 or 4 different databases, that you have to be knowledgeable on how to use 3 or 4 different databases, how to get at them. So you got to learn the different APIs. So it makes your application much more complex. Each database has a fragment of your data. It gets worse. You have to have experts to maintain these databases. If you have 7 databases, you need 7 teams of experts. And these things are updated at different times and enhanced as new features at different times. You've got to have different experts that understand how these things work. Different experts to keep them operational in your cloud. Different experts to set up all sorts of things. Different security procedures. So each one has a different security model and a different. You have to people set up these databases who are experts in security in Aurora, experts in security in Redshift, experts in security in DynamoDB. Well, I can go on, but there are like 10. You got to have 10 different systems. You have to understand how security works and how to set up security in 10 different systems. Same thing with scalability and availability and backup and patching. Now you're not patching one database, you're patching 10. It's a really bad idea. And your application security is limited by the least secure database that you're using. Your availability is limited by the least available database you're using. Your reliability is least, you see it. Your performance is limited by the slowest database that you're using. It's not a good idea. Oracle, it's multi-tenant for the cloud, high speed in memory, sharding, native JSON data types. I call it JSON sometimes, JSON sometimes. There is no right answer. Direct RDMA ingest of IoT data. Cloud SQL, one SQL language that lets you, query the Oracle database plus object store plus Hadoop, all of that, automated machine learning. We take advantage of the new Intel persistent memory in our newest servers. We have tables that are blockchain, so the transaction type, is blockchain based. Spatial graphics, all the different kinds of, it's all in one system, in one autonomous system, in one highly available, secure autonomous system. Compare that with trying to operate 10 separate databases. It's just much simpler. It's much more reliable. It's much more secure, and it's dramatically cheaper. We're always adding new features to the Oracle database. We've added a bunch of new database security features where we watch users' behavior, and if it's suspicious, we let you know about it. We look at configurations, and if they start drifting from some standard configuration, we let you know about it. So Oracle Data Safe is available today, and no additional cost in the Oracle Cloud. All these features of Oracle Data Safe not available in any of the 10 separate Amazon databases. They need to implement these features in all 10 of their separate databases. So you can see, seriously, think about that. That's a lot of work. It's 10 times more work than we had to do. We have a new version of Clouded Customer. We have a Gen 2 version of Clouded Customer, which I think is a really big deal. Clouded Customer allows you to take the best database, Oracle Autonomous Database, on the best cloud infrastructure, Exadata, and put it into your data center behind your firewall. And now the Gen 2 is so much easier to install and run than Gen 1. We actually used our Gen 2 public cloud to manage the Gen 2 Clouded Customer. So now it looks exactly the same. The databases in the Gen 2 Clouded Customer look absolutely identical to the databases in the public cloud. Exactly the same. And later on next year, you will get the full autonomous database. You'll get the full Oracle Autonomous Database. Everything that's in the cloud will be available behind your firewall in your data center for the first time. And again, it's been a big effort, but that's where we think people are going to go. People are going to maintain some, especially our biggest clients, the big banks and insurance companies, are going to maintain their data centers, but they want an autonomous database. They want all the advantages of autonomy, and you'll be able to have databases in the public cloud and databases in your own data center in our Gen 2 Clouded Customer. The Gen 2 Clouded Customer runs on the new Exadata X8. We actually have 2 versions of the X8. X8 is, not surprisingly, faster than the X7 that came before. More CPUs, more cores, more memory, everything runs faster. So you got choice. You can run databases in-premise by just simply buying an Exadata. But I think where most people are going to go is our Gen 2 Clouded Customer, which gives us all the advantages of autonomy, autonomous Linux, autonomous databases, all the infrastructure managed, and very easy for your on-premise stuff to exist with the public cloud stuff. You can do development and testing in the public cloud. If you're a big bank, you can then deploy in clouded customer. And the way you move from Gen 1 clouded customer to Gen 2 clouded customer is some Oracle engineers show up, move a few plugs around, and there's no contracting. Your contract's unchanged. There are no new fees. There's no charge for any of this. We automatically upgrade you to Gen 2, no cost. And again, to me, the most important thing is in the middle of next year, you're going to have the full autonomous database, exactly what's in the public cloud in your data center. And as I say, we have two versions of the X8. We have the traditional X8, which uses InfiniBand. And then we have the new version of X8, which uses a fancy new converged Ethernet called Rocky. It's RDMA over converged Ethernet. It's the fastest Ethernet. It's actually faster than InfiniBand, believe it or not. But the bigger change is we use the new Intel persistent memory in our servers. Therefore, you get super low latency data access, incredible speed with the X8M. And all the X8Ms come with the persistent memory. The M, by the way, is for memory. We were going to do X8 PM for persistent memory, but we didn't have enough room on the cabinet door. These numbers are amazing. So comparing to AWS's and Azure's all flash storage systems, 50 times faster for latency versus AWS, 100 times faster for latency versus Azure. These are huge performance differences, obviously. Okay, moving on. We've been talking about our Generation 2 cloud being autonomous and secure. Well, Generation 1 cloud had a different set of promises. Remember, the promise there was you only pay for what you use when you use it. That means what they promised with the Generation 1 cloud, what they promised was it was serverless and elastic. In fact, Amazon's cloud is called ECC, Elastic Compute Cloud. It's in the name. Okay, this is the promise. Pay for what you use when you use it. To do that, you must be serverless, meaning when the application is not running, you're not using any servers, zero. And elastic means when you're running and you're using 2 cores and you suddenly need 8, it automatically scales up when you need it and scales right back down. So you only pay for what you use by scaling up and down while running. So how did that go? Again, serverless and elastic, that's the promise. Well, actually, one of Amazon's databases, a very simple one, called DynamoDB, is actually serverless when it's not running. You're not paying for any servers. However, most people don't use DynamoDB. Most people use Aurora and Redshift and RDS and a bunch of the others. And none of those are serverless, and none of those are elastic. You want to scale up? Take the system down. If the system's not running, you still have to pay for it. No servers are running. Too bad. So you have to pick a shape, 10 cores, and what happens when the application stops running? You pay for it. Compare that with the Oracle Autonomous Database. It is serverless. AWS Redshift, not serverless. Scales up and down. Oracle Database up and down while running. Amazon, you want to scale up or down? That's downtime. Fails over much faster, but patches itself. Patches itself while running. Amazon, you patch, more downtime. So the reality of the Gen 1 cloud at AWS is unbelievably, the elastic compute cloud is just not elastic. What if you need a 5-core VM? Well, too bad. You got the closest thing to a 5-core VM is a 12-core VM. They have 4, and then they have a 12. So if you need 5, in other words, 4 won't do, your next stop is a 12-core VM. You got to pay for more than you need. If you want to scale from 12 cores to 17 cores, well, any kind of scaling requires downtime. What if you need a memory of 1 core for every 12 gigs of memory? Well, not possible. The ratios are fixed and set, so you end up having to pay for more than you need. What customers really want is elastic compute. And where you just simply say this is how much, how many cores I want, this is how much memory I want, and get me more when I need it. When I need the additional capacity, automatically scale up. Just like the database. We're not talking about the database anymore. We're not talking about basic compute, basic storage. Why shouldn't it do the same thing that the Oracle database does, which is dynamically scale, serverless when not running, dynamically scale itself up in number of cores, in amount of memory while it is running? That's what customers want. And that's what we're doing. That's exactly what we're doing. Giving you pick the number of cores you need, automatically scales up while it's running, no downtime. Scales up while it's running. Same thing. What about storage? People want to pick an amount of storage, and then, but they don't want to pick some huge amount. They want to pick an amount to get started. So pick your starting amount of storage. As you need more storage, it will automatically scale up while running, no downtime. And one of the interesting things now with our new storage system is you can buy capacity and performance separately. You can optimize if you need a lot of capacity. Performance is not a big deal. You say, okay, I want this much capacity, but only this many IOPS. I just don't need a lot of performance. On the other hand, you might need very little capacity and a huge number of IOPS, and you can do that too. And no downtime, outage, scale up compute, scale up storage, performance. So you can actually have optimized for capacity and suddenly change your mind one day a month and saying, okay, this is the day a month I'm doing a lot of and scale, automatically scale up IOPS, and then you can scale it back down, all while it's running. Cluster networking. RDMA cluster networking, available today for high performance compute and for GPUs in the very near future. We now have Microsoft SQL Server in OCI. By the way, OCI is Oracle Cloud Infrastructure. I mean, I tend to say Oracle Gen 2 Cloud, but that's the infrastructure. Oracle Gen 2 Cloud has 2 pieces. Has Oracle applications, things like Fusion and NetSuite over here. But it's the same, by the way, it's the same data center. We have one data center with all of our services now. And that's an OCI data center. So we have infrastructure, which is really a separate business, if you will, from Oracle applications. But if you look at an Oracle data center, an Oracle Gen 2 Cloud, it includes the infrastructure piece, and running right on top of that infrastructure are our applications. So we now have Microsoft SQL Server in our Gen 2 Cloud, in partnership, in our expanding partnership with Microsoft. This new generation of block storage, and this is really cool. It's really, block storage used to be, it was all flash, or it was all rotating storage. You made these decisions, this was the capacity, and no more. Now, it's really a hierarchical storage system. So it includes rotating storage. It includes flash. It includes DRAM cache, if you will. So you've got this hierarchical storage system, and you simply separately configure capacity. So you're going to mix rotating storage, with flash, with a DRAM flash, and then you configure the capacity you need, and you pay separately for performance, and you pay separately for capacity. And again, you can scale up the storage, capacity, or IOPS, or throughput without downtime. Instance resize, same thing. Go from 2-core VM to a 4-core VM. By the way, this stuff is happening very fast. All of this stuff is happening in the next few quarters. You know, instance resize available. It's available this year. This year's almost over, but it's available this year. All happens and very simple message. It's scales up, scales down. You pick the starting points you want. You get capacity online as you need it, no downtime. And if there's nothing running, there's nothing to pay for. Elastic instances. Pick how many cores you want, pick how much memory you want, boom, go ahead and launch it. If you need more, you have a policy set. If you need more capacity, it will automatically add more cores, add more memory. Dedicated VM hosts available now. VMs are very convenient to use as opposed to a bare metal machine. So you get the benefits, the privacy of a bare metal machine, the security of the bare metal machine, and the ease of use of VMs. So what we do is basically, when you get our dedicated VM hosts, you buy some number of these, and sure enough, we use the perimeter control computers to create a secure isolation zone around your computers, so threats can't get in. So we create this secure isolation zone. Same technology we use, by the way, for our database, in Exadata, right? So in Exadata, we have dedicated infrastructure in a secure isolation zone. Well, I mean, not only do you have database workloads, you have applications running on VMs that access that database workload. And that needs to be secure as well. So you can use these dedicated VM hosts that are protected with the same technology, the perimeter control computers. And you buy some number of dedicated hosts, and that's what you pay for. And you can run as many, number of VMs you run can go up and down. It really doesn't matter and doesn't affect what you pay. Okay, we've developed some wonderful partnerships. In some cases, a large number of partnerships with third parties who are selling their applications, or if you said another way, selling their application services on our cloud. And we have a marketplace to list all these third-party applications. And we have lots of them. We have lots of them coming. And in addition to that, we have some very special partnerships, like with Microsoft, where we've actually created a high-speed link to connect our data centers to Microsoft's data centers, so that you can be using the Oracle Autonomous Database with Microsoft Analytics if you want to. No problem, you choose. You get to choose any of the Microsoft technology, any of the Oracle technology, mix and match. You know, preserve your investment in Oracle technology, preserve your investment in Microsoft technology. You can use all of the inventory and all of the technology in both of these clouds. They have a high-speed interconnect. The Microsoft Analytics are going to work great on top of the Oracle Autonomous Database because we got the high-speed link. And I think a great relationship with Microsoft. And Microsoft has a lot of good technology. We started by linking up our Virginia data centers near Washington, D.C. We've just linked up London, and we're doing Western U.S. government data centers, Asian, Europe. We're doing a bunch of locations very, very fast. In fact, when you see our cloud growth, I think that's one of the two most shocking slides I've got here. Okay, so we've got a very important relationship with VMware. We're the only cloud. We've got a close partnership with VMware. We just recently signed. And we're the only cloud that lets you manage your own VMware stack. What I mean by that, the VM stack that you're running on premise right now, the VMware stack you're running on premise, you really can lift and shift it intact to the Oracle Cloud. You can use your existing tools, your existing operational procedures. You can or you can take your on-premise VMware environment and link it up to OCI. And so you can get benefit of Oracle Analytics Cloud or Oracle Autonomous Database. So we let you really control version management, operations, upgrade time of the VMware stack, making it easy, enabling you to migrate from, if that's what you want to do, it enables you to migrate from on-prem into the cloud with almost no change, virtually no change. Very big deal, very important announcement. Available this quarter. And we're getting bigger. We have 40,000 customers in the cloud today, about 40,000 discrete companies doing a significant amount. I'm not talking about a developer in the Ukraine. I'm talking about a significant company that's doing something of note. They're using a significant amount of compute and storage, or they're running a Fusion application or a NetSuite application or something. They're doing something significant. Round numbers, around 40,000 customers. In 16 hyperscale regions today. We've been adding services, by the way, and you saw the list of services we're going to add this over the next 12 months. It's really kind of extraordinary. As, again, we march towards the ultimate goal of giving you a fully autonomous cloud, fully serverless, elastic, all of the benefits of not just autonomy, but all the benefits of what was promised to you with the Gen 1 cloud, serverless and elasticity. So we have 16 hyperscale regions around the world today. All the Oracle regions run all the Oracle services. So in all 16 of those regions, you'll find NetSuite. In all 16 of those regions, you'll find Fusion applications. In all 16 of those regions, you'll find Oracle Analytics Cloud. You'll find, in addition to, obviously, the autonomous database and compute and storage and all of that jazz. So all the services are available in all of the clouds, and that's our policy. Amazon doesn't do that. Amazon has, some services someplace, some services elsewhere. So this is what it looks like today, 16 hyperscale regions. This will be one of the most surprising slides I put up, because when we meet next year on this, we'll have more regions than AWS. It's stunning. It's absolutely stunning. We expect to add 1,000 new autonomous database customers, more than 1,000 new autonomous database customers this quarter alone. And it's accelerating. It's accelerating. It's absolutely amazing what's going on. But very, very, very rapid growth. Big brands run in the Gen 2 cloud. I'm going to go through this very quickly. Siemens is running a new SaaS service in the cloud. So they're building an IoT business on OCI. 7-Eleven running their stores on OCI. Chipotle. We do more than just restaurants. Cisco. Cisco is runs a big SaaS service, a SaaS security service on OCI. And they more than doubled their performance, but the most interesting, by going into a shared environment, by going into a cloud environment, dramatically more efficient, and much lower cost for them. General Electric did 50 integrations, 50 application integrations in our cloud in less than 2 months. Booster is running their application. They've got a gas delivery application. And they're running a combination of containers, Kubernetes, and MySQL. Not everything in the Oracle Cloud is Oracle Database. We have a lot of other technologies in the Oracle Cloud beyond Oracle Database. I mean, obviously, Kubernetes, MySQL, Microsoft SQL Server, goes on and on and on. We have a lot of different services. Circle K, they're a big Exadata Cloud Services customer. The state of Texas is moving their entire payroll system to our cloud. Over 150,000 employees and expecting to cut their costs in half. French government, social welfare project, serving 30 million citizens, running in OCI. Tupperware moved their ERP system, J.D. Edwards, from on-prem into OCI. And FireEye moved their SaaS system, their SaaS security system into OCI, and they just about cut their disaster recovery costs in half by doing that. And CERN cut the time of creating a cluster from half a day to 2 minutes. As we say, time is money. They're happy. True Green moved their ERP system to our cloud. More than 4 times faster, saved over a third of the money spent. Okay, I'm almost done. One more announcement, as my dear friend Steve Jobs used to say. One more thing. We missed you, Steve, by the way. Anyway, one more announcement. The always free Oracle Cloud for everybody. Always free. As long as you keep using it, it will be there. It will never expire. It will never go away. In addition to the free services, as an OpenWorld introduction, we're also giving you $500 in free credits. I'll tell you what the free services that last forever are, and it really is designed for lots and lots of different people. So developers, whether you just got into CMU or Caltech or MIT or Stanford, wherever, or USC for that matter, where your mother pretended that you were a... It's not in my slides, Okay. Okay, no more record player jokes, no more, okay, so I'll stop. Okay, so we want to get developers from all over the world. Whether you just went into the Technion, a Cole Polytechnique, you're an engineering student, you're in the Ukraine, and you're working on a farm, and you have a really good idea. The guys who built WhatsApp, Ukraine, worked out for them. Worked out very, very well. Anyway, free to developers, free to students. We're using it in our own Oracle Academy for our students that we're teaching. And all of our enterprise customers and everyone who works for our enterprise customers can get to work right away prototyping their ideas, prototyping new projects that they're waiting for access to the Oracle Cloud. There's no need to wait anymore. They can go ahead, log on, and it's free. And it's not just like the basics we're giving you access to. We're giving you access to all of our best stuff. The Oracle Autonomous Databases, you get 2 of them with 20 gigs of storage each. We give you 2 VMs with 1 gig of memory each. We give you 100 gigabytes of block storage, 10 gigs of object store, and 10 gigs of archival storage. We give you network balancing, notifications. We give you all of this stuff available to all of our existing customers and everybody else. That's a complete universe. Everyone who's a customer now and everyone who isn't. can go ahead and use it. That's a large number of people. Always free, 2 databases. Each database gets 1 CPU and 20 gigs of storage. Actually, and that's running on Exadata infrastructure. All running on Exadata infrastructure. This is our best stuff. This is our best stuff. It includes all the tools for development, whether it's Apex for you need a low code tool. SQL Developer is what we use to build our own applications. You're building applications extensions. You can use this facility. SQL notebooks for machine learning. And all the popular programming languages, not just Java, but Java and Python and Ruby on Rails and Ruby off Rails, everything. And compared to Amazon, we don't have an expiration date. We're not limited to one data. We give you our best database. We give you our best database. We give you all the tools. Amazon doesn't give you tools. They don't give you their best database. And your stuff expires. None of that is true. We give you twice as many databases, and they're autonomous databases on Exadata infrastructure, twice as many VMs, it never expires, twice as much object store, 3 times more block store, and it never expires. You can have it forever for free as long as you use it. So, everybody should leave now, open your laptop, log on, and give it a try. Thank you all very much.